Hello students, let us continue with the same exercise, that is 6.5. Today I will be sharing the solution of next 5 questions with you. I have shared already up to question number 8. So if any doubts are there, please send the comments. I can follow the same. And tomorrow we will wind up this topic, that is similarity, by finishing all the questions of the same exercise. And please prepare for a small test day after tomorrow, that is on Saturday, up to area theorem and its applications. So tomorrow, next 5 questions I will be sharing with you, that is onwards question number 14 to 17 and followed by a small assignment. So let us start with question number 9 today. Question is, a ladder 10 meter long reaches a window 8 meter above the ground. Find the distance of the foot of the ladder from the base of the wall. So now this is the ground, this is the wall, this is the ladder. So wall is standing at an angle of 90 degrees with respect to the ground. So draw the figure, and this is the ladder reaching to a window which is 8 meter above the ground. Ladder's length is also given, that is 10, lengths are in meters, and what you need to determine is find the distance of the foot of the ladder, that is C, from B. So you can see, as per the case study, when you will be getting the figure for the same, that is a right triangle in which two of the sides are there, and by applying your Pythagoras directly you can get BC, that is BC square is equal to AC square minus AB square. So 10 square is 100, 8 square is 64, 100 minus 64 is 36. So BC square if is equal to 36, so BC will be equal to 6. Please make a note of that. I hope all of you can do that comfortably. So this question was your number 9. Then let us come to number 10. A guy wire attached to a vertical pole of height 18 meter is 24 meter long. Now again, ground pole is also standing at an angle of 90 degree with respect to the ground, and height of the pole is 18 meter. Now a guy wire is attached to this pole. What does it mean, guy wire? Means this is a kind of wire which is attached to a stag consisting of wheels, and we can move this to keep the pole upright, because due to the weather conditions, sometime during your summers thermal expansion is there, so the wire can become loose or tight in winters also. So then there is a stag which we can move to hold the pole upright, so that we can tight the wire by pulling it up, but nowhere the length of the wire is going to be changed, which is given to you is 24 meter. So the question is, this stake, how far from the base of the pole should be driven so that wire will be taut? So now this is the position of the wire. There are some bends. So if I want to tight the wire, I have to move this stake here, and suppose now this is the position. From the foot of the pole I have moved, so this is the distance I need to calculate. So this is 18 and this is 24. Again we are back to the previous question. Like right triangle is there, you can name this triangle if AB is the pole, and at C the wire is getting tight. Now no bend is there, wire is tight. I am showing Here also the length is 24 and here also the length will remain 24. Make a note of this please. So that's why this stake is provided, just to keep the pole upright, as I discussed with you. Now BC square again will be equal to what? 24 square minus 18 square, and that you can calculate. This is 576 minus 324, 252 BC square. So BC square will be equal to 252 under the root. Now this is not a perfect square, so what you can do is you can go for the prime factors. So this becomes somewhere like 2 into 2 into 3 into 3 into 7. So this is a perfect square, this is a perfect square. So 1 2 for this, 1 3 for this, and root 7. So you can leave your answer something like this, 6 root 7. I hope that is clear to all of you. So in that way you can determine the distance, how far the stake was moved from the foot of the pole to keep the wire tight over there. This was your question number 10. Let us see question number 11 now. An aeroplane leaves an airport and flies due north at the speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. How far apart will be the two planes after 1.5 hours? So, as the directions are given to you, so better to draw all the directions. You just can talk about these are the 4 directions. From here you can take the starting point. If this is east, so this is west, this is north, this is south, and this is the starting point I am taking. So an aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. At the same time, another airplane leaves the same airport and flies due west. So when it is flying due north, suppose it reaches at A, and when due to this west direction, suppose it reaches at B. Now I need to determine the distance between these two. How far apart will be the two planes after 1.5 hours? And these are the conditions I need to follow. When the plane is flying due north, that is in this direction, now speed is what? 1000 km. Time taken is what? 1.5 hours. Here it is due west. Your speed is what? 1200 km per hour. And time is again same, that is 1.5 hours. No doubt I need to determine AB, the distance between these two planes after 1.5 hours. You see how nicely the question is put in application part of your Pythagoras. So if I am taking, these are the lines of axis, that is your north, south, east, west direction. Somewhere I am getting a right triangle, if you can see that. Now, if I can find the length of this, easily I will be reaching here. And for that, this is the distance traveled from O to A in north direction, and this is the distance traveled from O to B in west direction in 1.5 hours. And distance, all of you know, is equal to what? Speed into time. So here this is equal to 1000 into 3 upon 2. So that is 1500 kilometer. So 1500 kilometer, because when I will be applying the Pythagoras, I will be getting somewhere OA square plus OB square. So here you are getting this is 1500 square. What's about this? Again, distance is equal to speed into time. 1200 into 3 upon 2. So this becomes is equal to what? 1800 kilometer. So it becomes 1800 kilometer, that is whole square. So AB square is equal to, this is 225 and how many zeros? 4 zeros. 324, how many zeros? 4 zeros. So if you add 225 and 324, this becomes 549 with how many zeros? 4 ending zeros. So therefore your AB will be equal to somewhere the square root of 549 with 4 ending zeros. So to calculate this AB, what you can do is, you do something like this: 549 into 10,000. Why? Because I know that 10,000 itself is a perfect square, where 549 is not a perfect square. So again, what you can do, you can start with the prime factorization. This is all about this. So now you write down 3 into 3 into 61 into 10,000. Fine. So for 3 and 3, this pair 3 will be there. 10,000, that is 100 into what? 61. So 3 into 100 is 361 watt kilometer. Here you can leave your answer. So the distance between the two planes after 1.5 hour will be equal to 300 into under the root 61 kilometer. Please keep a check upon your calculation part, because marks are there. No doubt, question is belonging to section C, so you can leave your answer in third form there, that is root 61. So this is the solution for your question number 11. Let us move towards next question, that is 12. Question 12 is two poles of height 6 and 11 stands on a plain ground. If the distance between the feet of the poles is 12 meter, you need to determine the distance between their tops. Very important question. Alternatively, most of the times it is a part of your board examinations. So please keep a watch how to go for this. So you know the poles are always standing on the ground. Do that. Be practical in such questions. And do not forget that the poles are standing at an angle of 90 degree with respect to the ground. Suppose one pole I am taking is PQ and another pole I am taking is AB. Distance between their feet is given. What is that? 12 meters. The distance between the feet of the pole is given to you. And what is that? That is 12 meters. What you need to and the heights of the poles are also given. One is of 6 meter, fine, smaller one, and the longer one is of 11 meter height. So this is of 11 meter. On behalf of this information, you need to determine the distance between their tops. So this is the situation. If you go through the statement and draw the figure according to the information, somewhere this sketch is coming into the picture. Now what I need to do is, I need to determine the distance between A and P, that is AP I want to find. So do not forget that what is the topic which I am doing right now, that is the Pythagoras. And recall the Pythagoras, we just can apply to a right triangle, which is nowhere is the part of my diagram up to yet. So what shall I do here? Definitely the construction. What will be the construction then? I will try to make this PA the part of some right triangle. So construction is from P, draw any perpendicular PE to AB such that, now you studied all these things in class 9. As soon as I have drawn the perpendicular from P to AB, that is PE, what happens? This PQBE becomes a parallelogram. I hope all of you will be agreeing to me. Why I call this a parallelogram? You see, 90, 90, bilinear pair, this also will be of 90, and fourth automatically will be 90 by angle sum property of a quadrilateral. I called it a parallelogram, not a rectangle, because I know you are very well known to the fact that in a parallelogram with a vertex of 90, then that parallelogram is always a rectangle. So that you can mention later on also, but better to say that this is a parallelogram first. As you know, the rectangle is also a family member of parallelogram. Now come back. As I said, this is a parallelogram, so in my proof, as PQBE is a parallelogram or a rectangle, whatever you want to write. So am I clear to you that QB will be equal to PE? And reason you know all, opposite sides of the parallelogram are always equal. So then what happens? PE I am getting is equal to what? 12. Fine. Now this much length is 6, and this from A to B is 11. Also, your this side BE will be equal to PQ, is equal to what? 6 meter. So therefore remaining part, that is this much. Therefore AE, what is AE is AB minus EB. And what is AB is 11. What is EB is 6, and that will become is equal to 5. So now this much is 5 out of total. So BE is equal to 11 and A is equal to 5. I hope now we are towards the end of the part of our question. In triangle AEP, what do I need to determine? AP square. AP square is equal to what? PE square plus what? AE square. That is the Pythagoras theorem. So PE is 12 square and AE is 5 square. You are very much clear with that. 144, this is 25, 169. So if AP square is 169, so AP will be equal to what? AP will be equal to 169 under the root, and that is equal to 13 meter. So the distance between the tops of the poles will be equal to 13 meter. So such questions now you are watching are kept towards the end of the exercise. High order thinking. Why high order thinking? Because you have to apply the knowledge to come to the part that this is the application of Pythagoras, which is not the part of anywhere in the figure. So you need to do the construction, you need to bring that right triangle into the picture. That's why these questions are put towards the end of the exercise. So that's why I said important from the examination point of view also. So one more question I will be sharing with you today. That is number 13, and I think that is enough for today. 5 questions. Please sit and revise. Give a second thought always. Whatever you are doing, ask yourself how we did and why we did. So in 13th question, D and E are the points on side C and CB respectively of a right triangle ABC right angled at C. So draw the figure. This is the information given to you. So if ABC is a right triangle and it is right angled at C, this is also given. D and E are the points on CA. Here is D and E is a point on CB. So somewhere you can mark E is a point on CB as per the information. And then you need to prove AE square plus BD square is equal to AB square plus DE square. Fine. This you need to prove here. Again you see I need AB square plus DE square. So in my proof, simply first of all AB square. So AB square you see I will be getting from this triangle AB square is equal to AC square plus BC square. Is it or not? By Pythagoras. In triangle ABC. You need DE, so join AE also you need. AE square is there. DE you need. BD you need, so join BD also. AE square plus BD square is equal to AB square plus DE square. So join BD and join DE. Now I need DE also. So what is DE square is equal to? That is EC square plus DC square. EC square plus DC square. Again by Pythagoras. In which triangle? In triangle ECD. I need AB square plus DE square. Let us see. Add. So this is AB square plus DE square is equal to AC square plus your EC square plus BC square plus DC square. So my right hand side is okay. AB square plus DE square. I need AE square. Now you keep a check here. If I join this AE square, so AE square again somewhere I am getting a right triangle here is equal to AC square plus EC square. So this is your AC square plus EC square. If you club this, automatically this will be AC square plus EC square will be equal to what? AE square. Again by Pythagoras in triangle EAC. And BC square plus DC square, if you see BC square plus DC square, so that is in triangle BDC. In triangle BDC, BC square plus CD square will be equal to what? BD square. So that is plus BD square. So hence AB square plus DE square will be equal to what? AE square plus BD square. So keep on joining the vertices. So just in the beginning I marked that E here. Please make a note that was mentioned on BC, not on AB. So I shifted that to this part. Then I joined E with D, B with D, E with A as per my requirement, and straightway I applied the Pythagoras as per my convenience to get the result. And finally we reached there. AB square plus DE square is equal to AE square plus BD square. So that's all for today. Tomorrow we will start on words 14. I repeat, tomorrow we will wind it up. That is your exercise 6.5, followed by a question assignment of questions 5 least at least from the same topic, And day after tomorrow, I will give you a small test up to area theorem and its applications. So please prepare for the same. Thank you.